This question is from GATE 2014 Mechanical Engineering paper, set 3, question number 30. A drum brake is shown in the figure. The drum is rotating in anticlockwise direction. The coefficient of friction between drum and shoe is 0.2. The dimensions shown in the figure are in millimeters. The braking torque in Newton meter for the brake shoe is dash. Let's start by drawing the free body diagram of the given system. So if we detach the drum and the shoe, we get the free body diagram as, when detaching a body, we will have to apply the normal reaction. This normal reaction will also be applied on the drum, but since the load and the support are on this side, we can separate the drum by transferring the normal reaction. Let this normal reaction be N. Now because of the normal reaction and the coefficient of friction between the two surfaces of shoe and drum, we will have a frictional force. That frictional force can be calculated as static friction coefficient mu into the normal reaction N. So this will be mu N acting at a distance 100 millimeters from this supporting rod. Let the point O be the support point. So we will have our reactions over here. After removing the support, we will need to show the reactions. Let the reaction in x direction be Rx and reaction in y direction be Ry. Since this is not a moment resisting support, the resisting moment will be 0 here. Now we can apply the equilibrium of moment equation about point O. So we have summation of moment about point O is equal to 0. If we take the summation of all the moments caused by the forces here, we have 1000 into the distance is 800 millimeters. This causes anti-clockwise moment about point O. Let anti-clockwise be positive, so we get this as a positive moment. Further, the force that creates moment is this force, mu N into 100 millimeters. Distance between point O and the force is 100 millimeters, and that is why we will write it minus mu N into 100 millimeters. This force N normal reaction is also going to create a clockwise moment. This will also be negative. So minus N into distance between normal reaction and the support is 480 millimeters. So we'll just multiply with 480. All the forces that create moment about point O are being accounted for here. So that is why we write the RHS now equal to 0. We know the value of mu. Let's substitute mu and find out the value of normal reaction. So we have 1000 into 800 is 8 into 10 to the power 5 minus mu is 0.2. So 0.2 into 100 becomes 20N minus 480N is equal to 0. This gives us minus 500N. Minus 500N taken to right hand side becomes 500N. So we can write 500N is equal to 8 into 10 to the power 5. Let's find out N from here. N will be equal to 8 into 10 to the power 5 divided by 500. We get this as 8000 by 5, which is 1600. And the unit that will get N will be in Newton because all other terms are also in Newton. So get N in Newton. Now in the second part, we have the normal reaction here and the tangential force on the drum is with us. So we can apply this tangential force on the drum here, which is mu N, and calculate what is the total torque being developed on the drum because of this frictional force. So total torque developed on the drum, let that be T, will be equal to the tangential force mu N into distance between the center of the drum and this force, which is nothing but the radius of drum, that is 200. We get mu is 0.2. So let's substitute 0.2 into 1600 into 200. This is being calculated as 64,000 Newton millimeters. Because N was in Newton, this will be Newton, and R was in millimeters. So we have written millimeters. We need to convert this to Newton meter because we need to fill in the answer in Newton meter. This will be equal to 64,000 divided by 1000, which is 64 Newton meter. Let's go back and fill in the answer. Braking torque for the brake shoe is 64 Newton meter. To learn more about brake force, you can refer to the NPTEL video, Module 1, Lecture 4, Brake Force Distribution, Braking Efficiency and Braking Distance from the course of Vehicle Dynamics. This course is by Dr. R. Krishnakumar. He is from Department of Engineering Design, IIT Madras. I hope this solution will help you clear your doubt. Thank you.